here chatting to PPMA TV, sponsored by Markham & Marge, is the wonderful team. And when I say the team, I mean the entire team from Alrad are here to chat to us today to find out a little bit more about what they're up to. But I'm going to start off with our technical director, Ian, who's going to tell us a little bit about Alrad and look through some of the technologies that are behind us. So thanks so much for joining us.
Okay, no problem. Yeah, we're a machine vision and photonics distributor, so we supply components and cameras and everything to inspect visually or illuminate your product so you can inspect it. So we've got a range of cameras from very low-cost cameras to high-speed, high frame rate, 160-odd megapixels at high mega frame rates with fibre optic outputs, as well as standard analog outputs for the standard imaging ones. And from standard visual wavelengths also into the infrared and shortwave infrared and thermal, which is some of the bits we'll show you as well. We've got a few demos here, so I'll pass over to Mike to show you our thermal demo.
Oh, amazing, yeah, I mean that's fantastic, thanks Ian. Okay, so in which case I'm going to come over to the lovely Mike now, who I hear is going to show us a little bit about the thermal, which is what's going on behind us. This looks amazing.
So here we have a Workswell thermal camera pointing at the corridor, so that as people wander past and cover that little bit of machinery, suddenly all of the heat signature of the bodies comes up and changes beautifully, and there's nice colours that pop up, which means we have something to grab people and sort of start talking about. It's normally quite a good demo in that it's something that people haven't necessarily seen before, and it sort of at least grab them and start talking, see what we can do with them.
Yeah, absolutely. So once you've grabbed them and you've dragged them in and you've gone, let's talk about thermal. So as a business, why would I want to invest in thermal cameras?
Well, there are a lot of things that you can do with thermal that you can't do with optical. One of the inquiries we just had is somebody makes large rotation and moulded components, and they're having a number of failures. They want to be able to pressurise the container and then measure escaping air, which is a different temperature to the surrounding atmosphere, and it will then allow them to pinpoint exactly where the fault is. And in doing so, they can then repair the component rather than having to scrap it and remake it from scratch, which obviously costs them a lot more money.
I mean, that's a fantastic solution, isn't it, actually? Yeah. And actually for your customer, and in a time at the moment as well, where we are thinking a little bit more about costs and making sure we're not overspending, this is a really great solution for that. Your customers must love it.
Well, it's just an inquiry at this stage, but obviously we'll be talking to them to see what solutions we can offer, because they just want the camera, so even a handheld, just with a small handheld tripod, will probably be as much as they need. So a very simple solution that's easy to implement for them.
I think that's a nice way of putting it. A simple solution to possibly what could otherwise be a really complex problem. So fingers crossed, moving it forward.
Yeah, so that they have a problem that they can't solve at the moment. And this is potentially a way that they can actually resolve it and implement it, say, very quickly, which could save them quite a lot of money.
Great. I can't wait to see where this goes. So I think you're right. I think this possibly could be, moving forward, something that is going to be really cost-effective and time-saving. So absolutely. Fingers crossed. Brilliant. So you've got something else to show me. Oh, I'm in the way. I'm going to come this way. There we go.
So in this case, this is a motorised lens where you can control the zoom factor, the iris opening, and the focus point. So the demo is literally just it's cycling through, looking at the different components, and you can tell that each component is visible. So because it's controlled via USB, the camera can actually be physically mounted 10 metres away from the control system. So you can actually manage everything remotely without physically having to go up to the lens, manually adjust all the settings, and it's brilliant, particularly if you've got different heights of products that you're trying to manage through the course of the production line. So it's something that's only recently been released, and we've been seeing quite a bit of interest in it.
Yeah, and I think that's really exciting. You can actually see how it's all working as well there. So actually, when it comes to, you've got people over to look at the thermal, but this is really interesting as well.
It's a really simple demo, but it shows the concept beautifully. and I've even been complimented by the manufacturer of the lens on the clarity of the demonstration.
Absolutely. Wonderful. Well, Mike, thank you so much for showing me this. I think I'm going to move on and have a chat with Julian now. Is that correct? Yes. Hi, Julian. How are you doing? Hi.
Thanks, good.
Brilliant. So what have you got to show me?
Okay, so in addition to the cameras that Ian and Mike have been showing to you, we also do lighting, which is really important for the cameras. Lighting's really, really key to a lot of the machine vision applications. So we have standard lighting here, we have structured lighting with laser systems here. But in addition to that, we're looking at quite a wide variety of wavelengths, so not just the visible spectrum, we're looking from ultraviolet through visible, near infrared and shortwave infrared. This is becoming much more useful area in process and packaging to look for defects and things like that, so not just the visible spectrum. So we also have, for example, industrial cameras, which are, for example, we have a welding camera that can look at very, very high brightness situations and using a very specific wavelength can see what's actually going on. So yeah, there's quite a wide variety of wavelengths there that we're working on. Another application in that area, and particularly useful for this industry, is waste processing. So we have what we call hyperspectral and multispectral cameras. So this is useful for waste sorting. So if you're looking at lots of different plastics that in the visible wavelength they look pretty much the same, under different wavelengths like shortwave infrared and infrared, you can actually pick out different types of materials according to their wavelength characteristics. So we have cameras that can cope with that type of application. And all of these things wrapped up, the cameras, the optics, the lighting, we can supply as components, but we also supply as a package with complete systems. And we work with systems integrator. We have a systems integrator that we work very closely with, Observant Imaging, and they produce some very, very special systems for us, bespoke systems, where standard off-the-shelf doesn't fit the bill. So, and I can introduce you to Gareth as well.
Right, so I'm going to come around this way because last but not least with the team here at Albright to find out about the last side of things is the lovely Gareth. So Gareth, you're doing a little bit more of a tailored approach. So talk to us about how you get involved.
So I'm what they call an integrator. So my job is to take equipment supplied by a company like Alrad and put it together as a system. And I'm also supposed to ask questions like what and why and how much. And once we've got the what and the why and the how much sorted, my next job, and it's probably the most important, is to work out how to do the lighting. So with photography, just as in the world of photography, lighting is everything. And if you can't get the lighting right, then you really are in trouble. So once we've got all that in place, then we can work out how to do what people want, how we can do the inspection, how we can do detection of flaws and faults and all kinds of clever stuff. But it starts with the same basics that everybody requires in every business. So a good example would be, here we have a turbine drum weld, and we have an inspection software system that allows you to set up different locations of interest on the weld, which it then goes from one to the other. And the reason that's such a powerful tool is because it lets people identify for a given object things that are of interest for that particular type of material. So for instance, now we've got, in this case, we've got 4 or 5 locations of interest, and you see it moving. I can then go to full screen, and you can see it zooming in and out and over. Another example would be the same software being used here for inspecting, and this is one of my choice pieces of equipment, is a watch. And it's an old-fashioned watch. We can just see down the bottom in the back there, and it's a wind-up watch. And you can see here, you can see the spring, and you can see all the different gubbins, and the quality is fantastic. And again, just like with the weld, you can go into the full screen mode, and you can see all the detail, all the cogwheels, and of course, with both of them, lighting is everything. In the case of, can I show you this just behind you? Here we've got a lighting rig for the weld. Can you see that? Here we've got there's the lighting, there's top lighting, which is what we call fill lighting. And you might be able to get this later. Just behind, there's an old Samsung phone. And I've got some hippie psychedelics running on it, which is why, if you looked at this footage again, you'd see that there's all kinds of bright lights on it. And I can show you that if you just move to the side here, we have look back here, you can see that as I move this turntable, the light will change and you see different colors reflected. Let's go back there. And you can see that this is actually a living object with light moving across it. There you go. All kinds of reflections and blues and greens and purples. And that's important because the human eye gets very fed up with monochromatic or no movement. And the one way that you can always be sure that an inspector, when he's inspecting a surface, stays focused, is if you have some kind of movement. Hence the animated regions of interest, hence the surface illumination being animated. It's very important to keep the brain moving. Yeah?
I think that's a very, very good thing to do as well.
Okay, one more. Before you go.
Okay, last point here, and then we're going to hand over to the wonderful David.
So this is a project where light is used to digitize the surface. So here we have an object, a scratch, and what we're doing here is we're using 8 lights, 1 lens, 1 camera, and we're able to take 8 images, and then we're able to turn that into a 3-dimensional surface. And if you want to get this later, you'll be able to see that, there you go, that was the acquisition. So from a scratch to a digital 3D version of that scratch, less than 1 second, which is phenomenal, and all done with lighting and maths. There you go.
Wow, I think that's all I can say about that. It's really, like you said, it really is keeping it very, very interesting, and the lighting really does, make the difference. So do come down and have a chat with the whole team and find out exactly how they can help you with your needs.